Hyperion of Saturn. Saturn's moon Hyperion looks like a frosted honeycomb. The 360-kilometer long moon is one of the most bizarre looking objects in the solar system. Its last good look at the strange little world. In 2005, the false color image of Hyperion revealed a world unlike anything else in the solar system. But unlike most other moons in the solar system that spins like a top around a fixed axis, Hyperion tumbles. It rotates chaotically, meaning that up, down, left, and right are more or less random, a non-pattern produced in a part by gravitational interactions with Saturn's giant moon Titan. So there was no predicting which part of the moon it would see. It is learned that Hyperion's unusual appearance can be blamed on its extremely low density. It's roughly equal parts space and substance and about half the density of water. The Hyperion's gravity is so weak, any material that's blown off during impact just keeps flying into space instead of falling back to the surface and obscuring the crater's original shapes. Formation of Hyperion is due to collision of many moonlets. The collision is due to the gravitational pull of Saturn being greater, which is 95% greater than Earth. Hyperion has an unusual appearance and behaves differently. This is not the only moon, and many planets have moons like Hyperion and they have their own properties. Then let's have an overview on the neutrinos. A gliding neutrino. The differences between neutrinos and antineutrinos might help to explain one of the universe's biggest mysteries. Some 13.8 billion years ago, at the time of Big Bang, every particle of matter in the early universe should have been created together with a counterpart called antimatter. Antimatter is precisely the same as matter but with some opposite physical property such as electrical charge. After 10 years discovering the neutrino, the Russian physicist proposed a mechanism for how the balance or symmetry between matter and antimatter might have come to be violated. One of his suggested reasons was that their symmetry was not perfect and that each exhibited slightly different properties. This difference might have led to a surplus of matter during the cooling that took place soon after the Big Bang. A particle physics experiment called Tokai to Kamioka or T2K, run by an international collaboration of hundreds of physicists, is now offering a hint that he might have been. The T2K collaboration measured the probability that a neutrino would oscillate between different physical properties during its journey in the experiment. The team then ran the same experiment with antineutrinos and compared the numbers. If the matter and antimatter are perfectly symmetrical, the probability should be the same, but the results, however, suggest they are not. T2K detected a higher probability that neutrinos would have changed properties during their journey and a correspondingly lower probability for antineutrinos. There is the existence of only neutrinos. There is nearly no antimatter left in the universe. Let us see and get to know about the infrared steam from the space.